Network flows, network flows, network flows, network flows. What the heck are they? By definition in graph theory, a flow network is a directed graph where each edge has a capacity and each edge receives a flow. The amount of flow on an edge cannot exceed the capacity of an edge. In other words, network flows are a way to model the movement of goods, information, or any other resource through a network. Let's first start by constructing a graph by adding some nodes. There's one source node as well as one output node. All traffic starts at the input and will end at the output node. Between these two start and end nodes, there are edges and other nodes that the traffic uses to flow through. Each edge has a capacity for the amount of traffic that flows on it from one node to another. This is called flow constraint. Another type of flow constraint is flow conservation. This is the principle that the total flow entering a node must equal the total flow exiting the node. This, of course, does not apply for the input or output nodes. This principle can be described with this equation, where f is a function of each edge in the network, and the total sum of the incoming flow is equal to its outgoing flow. Another key concept of network flows is max flow. Max flow is the highest possible rate at which a resource can be transported from one source to the output while adhering to all capacity limitations. Think of max flow like this waterfall. It is dumping all of the water into the output, the river. Because in most networks, we want to maximize the flow of resources, we use this concept for optimization. Optimization. Why exactly would we want to optimize a network flow? Well, take this for example. Right now I'm driving home for Christmas. The source node is where we start our trip, and the destination is our output node. The cities and stops in between are the nodes, and the highways are the edges where each road has capacity and flow. We probably don't want to spend forever on the road, and I'm too lazy to use a map, so let's use an app like Waze. Waze will optimize our route so we can get to our destination as quickly as possible. I wonder how it does that. Algorithms. We use algorithms. We want to optimize network flow. We use algorithms such as the Ford-Fulkerson, Edmund Karp, or the Dinix algorithms. Algorithms like these help us to optimize our flow to try to achieve maximum flow. It'd be nice if traffic flowed as nicely as that river. Well, what are some other examples of network flows? Well, anything involved with transportation can use network flows and optimization. Think of airports. Each airport is a node, and the plane has a weight capacity. You and the airlines want to maximize the flow of these networks so you can get to your destination. Say you order something off Amazon. It often has to fly from a warehouse, and then to a delivery truck, where it will finally reach your house. You can use network flows to optimize all these things and get your packages in 2 days or less with Prime. In the transfer of data and communications, we don't want it to be slow. I want to watch this episode on my phone right now. I've been waiting a week for it to come out as it is. If we want to send a message from this space station down to Houston, our traffic has to travel across many satellites and ground stations before it can eventually reach its destination. We can use network flows and algorithms to optimize all of these things so we can quickly get to where we need or get the data we want. So that's network flows in a nutshell from VR. I hope this wasn't too boring or weird and that you learned something about network flows. I haven't edited it yet, so I don't know how it's going to come out. Well, hey, thanks for watching and best of luck on your finals.